Uh, Great. Hello, everyone. We are live. We are global. This is the sixth uh, uh, installment of potentials of e-commerce that Professor Muhammad Hajiaghayi have with Nishan regarding potentials of e-commerce, of course, and Nishan will give us a short summary of the events that we had it so far. And yeah, so we are live on Instagram, Twitter, LinkedIn, Facebook, and YouTube. If you have any question, please feel free to ask at YouTube or LinkedIn, especially, or Instagram. That would be the best. And yeah, Sean, it's all yours.
Yeah, good morning, good afternoon, good evening, wherever you are. Thanks for joining another installment of Monetization Monthly, Potentials of E-commerce. Very brief overview. We started with exploring what an e-commerce marketplace is, what kinds of concerns you would need to think about, what kind of algorithmic or system design is important. And then we kind of differentiated between digital and tangible goods. We talked briefly about privacy and personalization and what that means, how interconnected they are, and how do you kind of get the best of both. We also kind of took a brief detour into Bitcoin and blockchain technology with a featured guest speaker and lots of interesting applications in terms of marketplaces there. That was session 3, if you're interested in checking that out. We then kind of took a deep dive into ad platforms, both the supply side as well as demand side of ad platforms. And then we talked more about cookie-less world and essentially how can you kind of stay in front of ad technology. In this installment, we're talking about marketplaces, generally the different two-sided, three-sided, multi-sided marketplaces, and then requirements operating these marketplaces bring about.
Great. So I think that's a great summary of the sessions that we had and this new session that we have today. Again, please feel free to ask questions anywhere, especially at LinkedIn, YouTube, and Instagram. Great. Now, having said that, let's start with the multi-sided marketplaces. So it can be, of course, like 2. We are talking at least 2. And so depending whether like the platform we are counting as a side or not, then sometimes 2 will be just a set of users and the website. So that's a typical thing that we have it. That's an interesting one, but we want to go a bit more complicated versions. Like that, we have at least 3. So a good example would be Amazon, for example. So there are some of the customers. This is like an overstock as well. That these are some customers. There is a marketplace, which is in that case is Amazon, and these are some sellers of the items. So, and of course, customers, they try to buy, sellers, they try to sell, and marketplace try to match it. And I think a good understanding of these systems is that this is actually a problem that we are working a lot in more even theoretical computer science, that algorithms for matching. And marketplace generally means matching. There is some matching should happen. And almost in all these instances, we have some kind of matching. So sometimes it can be 3-dimensional matching in some sense, but at least 2-dimensional matching. And because of that, the matching algorithms and the way that we are using, it's very important. Of course, this is if you are familiar with the matching problem. So matching, what is the matching? You have essentially, you can say a graph, a bipartite graph. There are some nodes here and some nodes here. And there are some edges that who wants to connect to what. And we try to generally generally there is some constraint that each person should be connected each buyer or seller to connect it to one person, and then you try to find the maximum number of matches that you can do. Generally, this maximizes the efficiency of the system and potentially revenue of the marketplace performer as well. So that's essentially the matching that we always have it in the marketplaces. Yeah, go ahead.
Highlight this some more, I guess, right? So like one-sided marketplaces are generally you're buying from somebody. So as long as you derive value and you can kind of agree on a reasonable price with this person, this entity, more relatively fixed, you can kind of strike your deal and move forward with your transaction. When it comes to multi-sided, things become a lot more complex because these different sides are kind of interdependent with one another. So usually there has to be a market maker in the mix. And this is the platform that allows these multiple parties to come together and each have their own kind of, like each side of the marketplace need to be able to satisfy their own constraints, as well as kind of the platform itself needs to be able to satisfy its own constraints for kind of the transaction to move forward in a multi-sided marketplace. There are kind of many examples of this that are may not be as obvious.
I think before going that, let me just, I wanted to add a few things here. I think that would be interesting. I think thanks for I think that was a good explanation. That we had about this. But also I wanted to add that, when we talk about this matching, generally, I think the constraint that you have mentioned. So these are some of these constraints that a seller has a certain number of items to sell, for example, or a buyer generally wants to buy one or too many. And so that is this type of constraint. But there is also another side of constraint about the time constraints. We need to do this kind of matching, or like the market essentially maker job, in a very fast way, because like you click and then essentially you decided that this guy, like for example at the case of Amazon, that when you click on this item, then not only the seller should sell it, but Amazon should also decide potentially the way that they ship that one to you. So it's like a very complicated, and everything should be done like essentially within less than a second, or like maybe 1 or 2 seconds. So this is the one that actually makes design of such marketplaces very complicated, because these are not just some people things that you can run it. You need to do everything in parallel. And one thing that generally helps a lot is lots of pre-processing that we can talk about. So we will talk a little bit about architecture of these type of things later in this session. But so just finishing about the two-sided markets, like we talk about, like two-sided like a website, then three-sided, like a simple example would be the Amazon or Overstock, that the buyers, sellers, and then like the marketplace platform. And then we talk about more than two, like you can think about Uber Eats or DoorDash, that here we have vendors that they are selling the foods, then we have drivers, and then we have these people who are ordering the foods. And of course, the platform, which is the Uber Eats or DoorDash, who is running this whole things essentially. And this is generally become very complicated. I had, actually a professor that was working on some board meeting with her, and she mentioned that in social sciences, generally, when we consider about two people talking, that's much easier to find an agreement. And here in agreement is essentially is doing the job done. When become three people is much harder, and 4 is almost impossible to make agreements. Of course, we may need to do it 4, but I want to just say that the complexity of the system, so it is complexity of negotiation, that is some negotiation is running on the back end. That's important. And on top of that, everything should be done within a second. You should get the answers, and that's important. Now, having said that, I think, Nihal, you wanted to continue about talking more about this.
I think the key here, as we've kind of mentioned, is like the different parties, all the parties need to satisfy their constraint for the transaction to occur. I just wanted to call out some examples of marketplaces that are maybe like less obvious and but have existed for a long time. Dating clubs, for example, dating apps as well, right? That's also a marketplace of sorts. Like you're trying to match a person with another person, and then there's usually intermediates. Previously used to be people doing these matchmaking, and then that has moved online as well. Financial exchanges are also marketplaces of particular sort, like for a financial transaction to occur, the kind of buying price and the selling price needs to match. Real estate is also another example. eBay has been in a marketplace, two-sided marketplace for a long time, and a lot of sellers explore the right kind of price to offer things at. Ad platforms are obvious examples, as well as kind of a lot of video games as well. When kind of yeah, so I think these have existed, like marketplaces in general have existed for a long time. I think what we're seeing recently with kind of the ride sharing apps as well as kind of delivery apps is like these have become massive marketplaces currently. And so like when you want to find somebody to date or marry, you have a much longer timeline. You're willing to wait a month, multiple months maybe, to kind of find the right person. But when you are looking for what to eat right now, you want something fast and ready, right? Which has brought about a lot of kind of technical challenges in terms of implementing solutions for these marketplaces as well.
Yes, actually, I wanted, I think two point that you mentioned, it is important. So when we talk about these marketplaces, that is, so we will talk about essentially some graph for the matching. This is one side, the other side. Interestingly, this both sides can be the same thing. Like, for example, for the dating, these are the same set of people here and there that you try to match. Of course, not the same person you try to match with the same person, but other than that, these are the same type of people, and you try to do a general matching, essentially. It would be, in some sense, a general matching in a graph version. So that's one thing. The other interesting thing also about these hidden things that you mentioned, and that actually is a very big business. Again, I had some of my friends that they're working on this business of like the brokerage. So that also is like the things that you may go to a brokerage and you are buying and selling stocks. And that is also another place that's actually the market making is going on. And this is also again the one that are more hidden. These guys, when you sell and you buy, this is the type they are giving you some price for sell and some price for buy, but this is not exactly the thing that they are doing. So they may actually take it for a short time for them. They may sell to you to this price, but they may not buy from the actual market until something like a little bit later, because they can predict that out of this the price probably go down and they can buy that one cheaper, essentially. And there is some kind of surplus here that actually that's the main money that they are making. So these are like the way that it, or like again, in some sense, also somebody wants to sell, somebody wants to buy, you try to match these guys. And again, you can do it at a different time, possibly such that you can do it with a different price, at any price that you will gain, that would be your price. Of course, you may lose, but if you know, due to history of these things and like a good AI or ML algorithm, possibly you can gain something out of it. And generally, the risk here, it might be a bit lower because these are your customers. You decide there. There is no need to be. I mean, this is not. Yes, there is like a one price, but this is that you can see it at any time, but that may changes in your local marketplace. And you can say, so these are lots of obvious ones. And this getting money out of this kind of matchmakers or marketplaces is like probably one of the essence of the whole e-commerce, retail or anything beyond that. Yeah, so that's the thing that I wanted to.
Yeah, and I think one other thing that's good to call out is like you need both sides of the marketplace, or like all the sides of a marketplace, to be healthy for your marketplace to thrive. So you can't sell if there's no buyers, you can't kind of buy if there's no sellers, right? It gets further complicated when there are like additional multiple sides to a marketplace. So for food delivery, for example, you need to make sure that you have a group of people that are willing to deliver food, a group of customers that want to purchase food from somewhere, and then a group that is producing the food, the restaurants, right? So as marketplaces get more complex in their structure, I think this constraint satisfiability becomes more and more complex in terms of how to formulate the problem. Like you need to make sure like all sides are kind of happy, and that can make the problem quite more challenging than just simply, one-sided marketplaces. As long as you fix a price, you can do the trade-off between the price and the volume. I think with multiple sides to the marketplace, there are additional constraints in terms of, can you bring about participants for even the transaction to occur?
Great. Actually, I wanted to add also one other aspect to that. I think it's somehow related to the one that you mentioned. So in some sense, I mean, like when we consider the matchmaker, I mean, they're like dating sites. Then yeah, you will go and I mean find the date. And so the good thing is that the people are online. You can also think about, I mean, Facebook in some sense is some kind of marketplace. You can think about it. But the one thing, I mean, good about these things is that generally all people are online and it is much less complications. The complication comes generally for companies that they are also doing heavy operational stuff. What are these operations? Just think about, for example, Amazon or Overstock or others, that they are shipping the items. Now, actually, Walmart. I don't know. Have you heard about it? There is a Walmart Plus as well that is doing like that's Amazon Prime essentially. So they are also delivering. Now, when you are doing this delivering, it's a lot of operations that you need to do that. And interestingly, if you think about as a startup, these are like the hardest one to make it. It's not that easy because now you need to deal with lots of drivers. Potentially, I mean, one important thing almost in all of them, like Amazon versus like DoorDash or Uber Eats, there are some kind of essentially driving the car or delivery. That's this concept that this is also, it is another thing that we will talk about. This is kind of working with some kind of special data sets. That's also another thing that we will talk about them. But the fact that we have these operations actually make the whole things much, much more complicated because now it is not something online that you will do that and you will answer the messages like, for example, like WhatsApp or others that you are answering, but you need to actually talk with this kind of lots of delivery issues, lots of delay issues that may happen. And as Nishan mentioned also, it is important to have the customer satisfied. And here, in some sense, the customers, you can think about all of them. So that's a good thing that when I was at Amazon, I think I liked this particular thing about the customer obsession that they had it at Amazon. And yeah, I mean, there are some other things that I didn't like there, but about the customer obsession, actually, it is interesting. So in some sense, there was during the discussion, when we talk about customers, so like here in this case of marketplace, of course, the sellers would be one customer, buyers would be another customer. And interestingly, they also consider Amazon Finance as another customer. So in that sense, everything was like a customer, and we need to have a platform to satisfy everyone. And so in that sense, so this is like a really three-sided case you can consider it. But so we need to satisfy these guys, because if one of these markets, one of these groups essentially is out of game or not too much resources there, then we have a problem. That is one of the issues that, for example, we had it during COVID, as we talked before. Yeah, go ahead.
Yeah, no, I was just gonna kind of call out like another thing, like when we're talking specifically about these transportation, like logistics oriented marketplaces, is that you need to satisfy for each and every customer locally, right? Because if I am looking to buy something in New York and you're in Maryland, like I can't add drivers in Maryland. I have to find drivers in New York. And the same thing, so this balance for the marketplace cannot just exist globally. Like if you're shipping packages and there is like limited number of things, you can still distribute it as a global optimum. But here for these kinds of marketplaces, they need to be kind of optimized for each kind of local sub-market individually. And so I think this is kind of where you're going, like with the pandemic. We saw like massive surges in demand and lots of kind of interesting challenges for the marketplace. So do you want to talk about that some more?
Yeah, so that's actually a good thing that you mentioned. So this is like maybe I think we mentioned about those that they don't have this kind of delivery or operational things. Like for example, at Facebook, if there are more, I mean, that happened actually during the COVID time, that people were just behind their computers or their cell phone. They were just, everything was online. So there, of course, there are much more, in some sense, surge in the demands, but then they could just open, I mean, if you consider the Kubernetes, then you have a bit more of service servers that you will open, and then everything will be fine. And you have the scalability, everything, some microservices, you will just add a few more and everything would be fine. But here, as you mentioned, this is not the case that, I mean, like, for example, if you need drivers, like this is the case that happens, I mean, quite a bit for me, that, for example, you want to go, you're at the airport sometime, you want to take some Uber or Lyft, and then you are thinking, I mean, the cars are there, but because of lots of customers are there, you may not get it actually the time that you want it. Now, for example, if I'm in my home and I wanted to get delivery of the food, that generally happens maybe easier because more spread. So in some sense, there is this concept of surge that is happening. So I think this is the one that I heard some talks or workshop that I had it with Uber, that was, they were discussing explicitly about the concept of surge, that some area there is more demand. And this is actually also, if you search online, there is this concept among drivers is a very typical thing, that there are some places that the demand goes high and there is some kind of surge. And then in this case, we need to actually somehow satisfy this. So now, if you consider this concept of surge, this is the one that happens, for example, during COVID, that, of course, I mean, like, probably at the beginning, at least the production was there. The customers were there, the demands were there, but the people essentially didn't want to travel, or because of any reasons, like the people wanted to, maybe also some people actually found, because that was one other issue, that you could find possibly easier job means remote jobs. And
people didn't want to expose themselves to kind of COVID by driving around.
Yeah, right? And also, I mean, I think I will say that the money also was probably even higher on those things. So you could essentially sit at your home, you earn some money through one of these online services, and you don't expose yourself to COVID. So these are the drivers that they were not there essentially. And of course, then this is, I think, the other issue that we mentioned, when the drivers are not there, then this producer will not produce that much as well now, because they cannot, essentially give it to the customers. So now, and then the people who are producing that, they go out of essentially job. They will maybe find other jobs. So the whole thing happens, something that like essentially 1 year after COVID, still we have this problem. So sometimes this concept of equilibrium is very important. And this is a very complicated system. I think this is actually the things that I heard in another workshop actually with Michael Jordan. He's a famous computer scientist at University of California, Berkeley. He's doing a lot of MLS stuff. And he was mentioning that, just think about the way that in the US, actually that he mentioned before COVID, the fact that, all these ingredients of all the foods and other things come in US all at time, and we will get it. This is completely non-trivial thing. Actually, I had some ideas there and say that I think he was actually talking about game theory is very important, because all of the incentives of the people that in equilibrium, we will get everything. And maybe at that time, I didn't have that good, didn't quite get it. But now after COVID, I completely understood that it was really a non-trivial thing, and a little bit, problem in one side can essentially kill the other side, and we can have a massive problem. Yeah, go ahead.
And it's both sides, right? Like the case you described was like when there's, let's say, a shortage of drivers, and there are people that want to buy the service, but like they cannot get it. And so they're unsatisfied. And then that kind of affects their experience with the platform and their inclination to use the platform down the line. The reverse can also be true. Like if there is a high demand, if you're kind of purchasing a lot, and then I guess, it is kind of fueled by the same constraint from kind of driver perspective. If there's few drivers, essentially you may either end up paying more, which is kind of the surge design, or you may also affect the quality of the item. So for food delivery, for example, if everybody's ordering from the same restaurants and they don't have the capacity to kind of fulfill all of these orders, then the quality of what they produce, as well as kind of the quality of delivery, may suffer. So this is like very interesting, like the increase in demand, increase in kind of desire of something actually degrades the quality of that thing itself. And the other side can be true in terms of if you're a driver, just, and this is how you make your livelihood, and you're kind of sitting around, you're not getting any orders, you're much more likely to kind of stay with the platform and kind of want to continue this same kind of service. So then you may move away from the platform, which may then cause further shortage and kind of like lack of, like drivers. So this, again, this equilibrium ends up being extremely important to manage on a very, very micro scale.
Great. And I think this is also somehow actually related to the one that you discussed as well. So in this, and one other thing that we mentioned, that the design of these systems are very important, because whenever, so there is like everything working is working, and we may not feel it like the way that I didn't feel it when Michael Jordan mentioned about this thing, that's very complicated things. But then if something does not work, then you understand how big is the issue. But like generally this happens that one side, essentially, like among few sides, generally, I mean, we say platform because the online things, it might be fine, but the operations essentially goes down. And this can be like about customers. Sometimes the demand goes up. Sometimes some of these things that we discussed, like for example, one of these side, like drivers go down, or maybe production goes down, like the vendors, they may have problems essentially. So, and when there is some kind of, I will say any of them happens, in some sense, the system goes out of equilibrium. And say, if we talk about the case of Uber, for example, I think that's a particular thing that I'm aware of it. And there are actually, if you search online, you will get interesting things about it. This concept of surge even is known among drivers. Mm-hmm. And I was reading actually some of this, because of course I knew about it, and this is the things. But then I was hearing this one from drivers, that they say that when there is a surge in some area, whether actually should. So what is the concept? The surge is that there is some demand is coming here, and we need to send essentially some driver to go there.
The demand is increasing in that area than it used to exist before, right?
Exactly. And now the catch is that no, this driver said that actually if you see the surge, and that was the idea that they had it. So at Uber, they could announce that, oh, this is the surge area, so you could go there. So as a driver, you have incentive to go there, and because there's a demand there. But lots of them actually say that when you should be very careful. You should just react to this kind of surge when you are very close by. If you are far from there, then when you reach there, there is no surge essentially. Everything is gone. So in some sense, the reverse will happen. That now there is not much demand. So in some sense, the reverse of that happens. So sometimes you have a huge demand here. The drivers are coming here, but lots of drivers are coming here. There is no demand anymore. So that's somehow the reverse happens, and this should be done in a very this is very delicate things, and even designing such a surge system. So it is not that easy. That send more drivers. That you make it actually more inefficient unless you send the right number of drivers here. Because these drivers, they may go from the other side of the city to here. So there's nothing essentially here. And essentially they lost a lot of money in terms of fuel and other stuff
And
That is
the other side of that surge is like how much customers get charged, right? So a lot of times, like I've seen these prices go up by over 100% during surge periods. Um, so then the question is like, how is this algorithm set up, and what kind of gamification of that happens? A lot of times, like I've noticed, um, like some common features for surging is like if you check the price and you're in an airport and there are like others around you that are checking price, then it usually goes up. If you check more than once, then it usually goes up some more. So yeah, to that thing, I think what that then incentivizes is for customers to kind of check on multiple apps and kind of provide the platform with less information, because any information you provide the platform like may be used to kind of like charge you more, which leaves the platform in a not sustainable, right? Like you're training your customers to shop around and kind of not have loyalty with your particular marketplace. So I think longer term that leaves the marketplace in with like less loyal customers, less retention, and more ability to kind of move around. And so that kinds of things also become really important to consider when you're thinking of these marketplaces and how you design them.
Yeah, so great. So I think like a summary so far, so we just talk about these marketplaces so far. I mean, we just give some examples, some like more obvious ones, some non-obvious ones. And we are talking, especially the case that some operations come to the place. And that's the one that would be the problem, because much more interesting and at the same time, much more challenging. And one issue is also that makes it, so generally when we are doing online, we tend to find fast solutions. But here, when we talk with operational things that actually are not that fast. So if some driver essentially you want to, I mean, that may happen actually. You want to send the driver, and that driver, the car maybe is broken. So in that case, I mean, like then you need to find another one and go somehow replace that car. And these are not that fast things. At the same time, and as we discuss also this concept of surge that may happen, and you try to resolve this issue by sending more resources there, but you need to make sure that you don't send too much resources there. At the same time, I think also when you do the surge, yes, you may want to increase a little bit the price, but you should be careful that you don't increase too much the price, because the customer will be unsatisfied during this time. So it's a lot of things that you need to essentially think about it. And some of them, of course, these are some kind of more like the optimization problem that you need to do it. Lots of them are ML stuff that you need to understand, like this kind of time series understanding, that what will happen generally from the history, what you should do it. And as we know, some of these are lots of them, these are essentially related to time series. And some of these time series are not that easy to do that. Like, for example, a stock market, it can be very complicated to do it anything better than 50-50, essentially, things. So these are like a complicated problem that need to be handled in a very fast way. And I think to want to add maybe a little bit more about it. Now we want to talk about a little bit about the back end of this and what can we do. But before, I think you wanted to also talk about the network effect that may happen. That's like another interesting
so
thing.
I think we kind of touched on it like a little bit, right? I think fundamentally network effects boil down to like your action as one node in the network has consequences for subsequent action across like all the kind of participants in the network. So your action as a customer to order from a particular restaurant, if everybody else does the same, affects kind of the quality. That's one example. Driver shortages as well, right? Like if all people concentrate from kind of purchasing from one place, that leads to possibly a shortage in drivers, or a lot of customers are concentrated at the airport, let's say, and they want to order an Uber. That leads to kind of surges in demand and price. So when you're making decisions in a marketplace, these second order and third order effects become extremely important as well. So like, for example, by having surge pricing and these surges in demand, the volatility of surges may make drivers like spend a lot of time just trying to get to hot areas. So they might end up being less efficient. And the other thing is they may not want to take orders that are not surge orders. So that may kind of change the fact that you have surge pricing might lead to an uneven and imbalanced distribution of your drivers themselves, because they want to compete for those like high value kind of slots, or like deliveries or kind of rides. So essentially just kind of calling out that these systems become a lot more fragile and much more important to be able to inject kind of robustness into these systems. And one rough way to kind of at least think about it is like, if we have captured the value and we've distributed the value for each part of the kind of marketplace, I think essentially eliminating opportunities for gamification, because these gamification may have multiple subsequent effects that may not be desirable. So trying to capture the appropriate value of each transaction and being able to encode them appropriately in the marketplace, I think would be one way to kind of look at these network effects. Curious if you have like more thoughts on that.
Yeah, so actually, I think you implicitly defined the network effect, but let me, say maybe from the, more perspective. So generally, you have a network. A network is a graph. And the network effect is that, you may do something, and this has some effect in your neighbor. And then that effect essentially then has some effect on the neighbors of the neighbors, and so on and so forth. So just one thing that happens, it may actually have big impact on the other part of the network as well. So I think to maybe make a clear example, in that case, the one that we talk about, the search. So there is some demand is happening here. I don't know. The people are going to a stadium or some other things. They want some kind of end of the game, like the World Cup. So probably Qatar is not such a big country that you have the problem there. But say other places that you have, the people are going to some place, then they want essentially a ride. So a search happens. Then you are sending the drivers to here, and lots of the drivers, if you are not careful, if you send it to everyone sees this is the fairest thing. They say, okay, let's go there and try to give the ride there. But at the same time, you are depletes essentially part of the essentially driver from the other part of the city. That now, the next event actually may happen in another place. And here, if it was like generally these people were there was no issues. But now because you pulled all of these drivers from there to here, now this is something bad happens in like this, there is a demand here. And maybe again, it takes some time. These people are unhappy. You need to send the drivers from some other place. And then those places may happen essentially. So you may have essentially a very bad day if you are not careful and pulling essentially drivers from one place to other places. Essentially, you are wasting their time and their gas, etc., because they will go there and then there are just too many of them there. There is no demand here. At the same time, there is other part of the city is the demand. And if you just don't think about it, you just do it a few days like this, you may lose essentially your customers and your drivers and everything. So these are very important things that it is it might be actually safer to don't say even that there is a search here. Probably, I think that maybe in the food delivery things, maybe it's a bit, you may need to have this kind of search things, because then, if you get the food, it did happen to me, for example, for Uber or DoorDash, that, they come essentially, sorry, we were supposed, I think I got it sometime even 1 hour later, the food that I ordered. So it's not that a big deal. But of course, for people, it's a bit harder for riders that they are like in a very cold weather, you need to send the thing. Otherwise, they will be also not satisfied. But I think the whole idea is that this kind of network effect, that you will change some of this. And in some sense, this is the platform that is changing some part of the things. Because of some dynamics that happens, you try to react to that. And this reaction, if it is not correct, actually can cause some other parts of the network that suffer, that part caused some other parts of the network suffer, and so on and so forth. And again, it can be very bad and essentially killing or for killing event essentially for anything that you are doing. So you mentioned about the gamification. So what? So of course, this is some kind of gamification here is going from the platform. It try to somehow handle that. Are there other type of gamifications here as well?
Yeah, I think like just generally, I think this is such an open space, right? Like in terms of what kind of incentive programs can you create for participants in the market, and then do they lead to more volatility and more, negative networking effects, or can you make the system more robust with these kinds of effects? So we talked about kind of surge pricing. Fundamentally, I think it comes down to, right, like I think the nature of how these drivers are getting paid. There is probably a bigger cut for surge like delivering or fulfilling search requests than it is for other ones, which is why these drivers are consciously seeking out the surge kind of demand. Another example could be tip. Like certain customers, certain like people in certain places maybe are more likely to tip than others. And then there may be, like other kinds of incentives that the marketplace creates. For example, you could reward number of trips versus length of trips. So if you're incentivizing drivers to take more number of smaller trips, then, like your drivers may not want to accept one of these rides that are longer duration because they're less incentivized. So then you create a gap in the marketplace, not in terms of like location, but in terms of kind of distance you want to go. And this is something we fairly common, right? Like we see in terms of, at least for in Nepal, like almost no taxi would operate by the meter. You had to negotiate a price with the cab driver. And there were all sorts of arguments the cab drivers would make in terms of price negotiation. Usually when you had to go like far out, they were not very inclined to kind of take these rides because they also need to think of how they're going to come back. As long as there's demand the other way around, then they are willing to take these trips. But then they need to also think of kind of what this cost kind of downstream from them looks like. So again, how these incentive structures and rewards are created can cause deterioration effects in the network or lead to the networks being more robust.
Yeah, I think that's a very good point. So in some sense, we can think about this essentially the marketplace, or the platform is the one that somehow generates some rules that potentially, if can handle this one, especially I will say in a non-equilibrium sense when there is a surge or other things happen. And for example, one other interesting example, it is like this, that Uber or Lyft, they have this thing that you can let them essentially know in advance that when if there is a driver and this if you are a rider, then this rider wants to say he or she knows that like essentially in 20 minutes the game will be over, and in that case then they can let the system know that, okay, I'm leaving in 20 minutes. That's a very good thing, for the people to let the system know, because then in that case you know how many people you need to have like send it here, and you can essentially plan more for that. But the issue is that at the same time you need to provide also the incentives. Why the incentives are important here? Because here you want to maybe give them some discount or others, but otherwise the people may not actually.
Yeah, I've actually seen the opposite. Like the charge for me to schedule an Uber ride was actually higher than to say, send me a car as soon as possible.
Exactly. So this is, I think probably that's one of the reasons. If you see, these are the way that it's like maybe something that can help. But if you don't design the mechanism correctly, and as you mentioned, if the people feel that, okay, if I do it now, they may give me some standard things, but usually I have things that I can get actually cheaper than that. They may not do it. And when they arrive it, then at that time, actually, they are. And or the other thing is that you may say that I'm doing it for 20 minutes. And it turns out that when you do such kind of things, I think that's another issue that I had it, that when you schedule it in advance, you don't get actually the person there right at the time. Or you are not sure that, for example, at the airport, you don't know whether you reach there even at the same time. So these are some of the things that like complications that the people have incentive to play the game essentially with the system. Either they don't report it truthfully, or they don't have any incentive to say that because they find some other options which is better for them, because these are selfish agents in some sense, which is and not necessarily the best for overall system. So these are some kind of like the game theory aspects that also happens a lot when we design such kind of system. So is there anything else that we want to cover regarding this one? We can, and then after that, we can talk a little bit about the backend as well, but go ahead.
Yeah, maybe let's talk about the system constraints and backend and kind of things to keep in mind for that.
Great. Okay, so let's just, here we try to, just think a little bit about the problems. Again, we don't try to solve the problem. Of course, these are the systems that are there, but we want to just mention some aspects that, if you are interested, actually, you may think about it. And this is also, if you are interested, if you have such a problem, we will be happy to help, essentially. Just let us know, essentially, Nishan or me, and this is my email is my last name, Hajiaghayi@gmail.com, and Nishan, your email is
Subedi@gmail.com.
Yeah, so you can just find us essentially, and we will be happy on that. But like these are the things that if you want to design a startup or something like this, that might be actually quite relevant problem. We just want to say a little bit about the complication of complexity of the system, and maybe dig into some parts of it. Of course, we cannot cover everything. That may take hours and hours, and this is not a state of the art. That there might be some other things that the people are changing. And yeah, we want to just give the idea somehow, that just maybe tip of the iceberg, we talk about it, not the whole things below the water. Great. Yeah. So just think about this one, that, for example, at Uber, say we have around, in US, maybe they have 200 million or like 150 million users. Just in US, we are talking about. Other places, of course, that can be different. And as we discussed, if there are some drivers and demands here, these are some kind of this here, and Europe maybe not that much related, generally. Even that is not completely correct, maybe because of some flights, etc. There might be some little bit network effect, essentially, is going between US and Europe, but probably we can say for now, ignore it. And so, yeah, so that's the thing. And say you have 150 million users, I will say 1 million active users like per day, or maybe around, say, 1 million ride per day, essentially. And then say you have 500,000 drivers. Again, these are some numbers, you can find it. I'm sure that you can find some of them much better numbers on the web, the exact numbers, but these are just some ideas. But one important thing that generally the people expect is the fact that these drivers, okay, so this is the one that we are talking more here, the delivery part, or the transportation part, or the operation part. Again, there are several other things. You may talk about the vendor issues, that they may have some delay, etc. But here we want to talk more about this particular issue of delivery, essentially, or ride. Which generally talk with some kinds of spatial data sets. And this is, again, the one very common thing, that as long as your app, your service essentially depends somehow Google Maps, then this kind of spatial data becomes very relevant. The traffic on the road, everything at some point actually may affect your system, and you need to think about that. And of course, Google Map is a good one that I think I have tried this one. I think the people should try to, just use the system, and it gives you can try some of them for free, but after certain, these are the things that it gives the service. After certain number of queries that generally done through API REST type of things, then you need to pay according to the number of requests that you have it. But before that, you can actually do it almost for free, and you should learn about this. I think that's a very good one that I will mention to students or others that, or anyone who wants to do that, try to use the Google Map things, essentially API. That's a useful one. Good. So these are we have some kind of special data sets that the people are all over the city or county or country in general. And this, the one important thing, so this is the main topic that we are talking about. And each driver should know, we should know the position of the drivers, like essentially all customers. So in this case, the customers, of course, like some say drivers, these are the riders, and you may think about even the vendors, that their location is good. But the good thing about the vendors is that probably their location is generally fixed. So you have a good ideas about this. But the customers, riders, probably also they are not bad, because when they come to the system, then their location probably will be quite consistent. Because they don't move. If they had a car or something, they move. At least we are assuming for now that they are not moving that much. But the main issue here is our drivers. Drivers are the ones that they are fast moving. And we need to have a system, a backend system that can actually capture their move, because we need to mention their location to the other customers, like for example, to the people who want to get the food, or to riders, or to vendors. And we need to report it. We need to have a system which can do that. So that's a system that we are talking about. And of course, on top of that, you can think about lots of auction is going on as well, that all sorts of things that we discussed, some of them, for example, for display ads in the previous installment of this series, actually, that all this kind of how much you want to pay to drivers and others, these are lots of auctions that are going there. But here, with this talk about these auctions, maybe we will talk more about them as well in the future. But here we want to focus more just the fact of finding the positioning of these guys. Do you want to add anything to the setup and other things?
Yeah, I think that pretty much lays it out, right? Like I think one of the biggest constraints here is that we need timely and updated information across all of these different drivers at all times. And even for the customer, like there may be many combinatorial degrees of calculations that need to happen in terms of like location and then distance calculation based on that, how quickly things can be delivered, what is available. And so, yeah, this, I think, just generally sets up for a lot of kind of real-time computations that need to kind of happen. And so if not designed carefully, like one, just the sheer number of computations can be quite like constraining, but also kind of the kinds of caching or system scalability approaches you take may not be as obvious. So there are few techniques that we can go into. Yeah. I think you're muted.
Yeah. So yeah, as you mentioned, actually, these are. This somehow system design. Like it's a complicated things, and it can become actually more complicated for this part of this type of design. We want to just give some kind of clue about this. And so this is also another interesting thing. So I think this is also the view that I have it. So you may, like the people may read lots of, basic data structure that exist, like, I don't know, binary search tree, heaps, stack, and other things. Some of them are now available in C++, STL, or Python, all of this. And some of them you may think these are just for the algorithms. Interestingly, some of these data structures are the one that it can be used for the whole system design. So that's, I think that's the beauty that I maybe came to that maybe at a later time. So at the beginning, so these are like, generally when you talk about a data system design, you will talk about the databases that you have, like some kind of relational databases that you had. You may need to have some kind of asset properties or other things that you can read about these things, and you want to get it like a fast thing. So for example, you may, if you want to use the fastest one, I will say that can, or sometimes there are the sharding issues and others. Actually, lots of them can be maybe now resolved, or you don't need to deal with it because of this new Google big table or big query type of things. So in some sense, this is the very evolving field. Lots of companies, like you can think about Snowflake, Databricks, and of course Google, the other like Azure or AWS or Google Cloud. These are trying to design some system for you such that it becomes easier and easier. But interestingly, and of course, when you try to deal with it, when you talk about sharding, for example, here you are using some kind of data structure. What type of data structure you have it? In some sense, the beauty is that you are doing some data structures on the databases. That's, I think, the general view that we have. But for some of them, like it might be not that, clean solutions as of now, and you may need to design it. But at the same time, also, of course, there might be some of these are available, especially about spatial things at Google Maps, but you need to pay for it because you need to, anything that you will put, someone should pay for it. And this is the typical thing, like, for example, for Snowflake and others, that they have this kind of fast thing that they are running a Spark. In parallel, they try to find, they do some operations on databases, but of course, they are also charging hefty prices for the service that they are giving. So in some sense, it may make sense that if you are a startup, you don't want to pay that big things. You may want to design some of them. And one thing that actually it works very nicely for this type of spatial data set, and this is like the view that I mentioned, these are the data structures that you are putting on databases. This concept of quad trees. So in generally, the quad trees, like I will say quad trees is one important thing. And of course, the hashing is another one that always we are using essentially. And the other databases that we are doing. And just give you some idea about the quad trees. This is, again, some kind of data structures that you consider the whole, essentially, say, page. And then you divide it into 4 places. And then you may recursively, each of these guys, you may divide it into 4. This is some kind of fractal. The catch is this one, that this is actually very good things. So why quad trees are important? This is generally, so you want to see that a customer, the rider is coming, or like make essentially a request, or a person needs a food. So essentially a customer appears somewhere in this plane that you have. Then the question that who are the nearest drivers that you want to do it? You want to get to this. This is actually a very nice data structure, this quad trees, that allows you to find it. Because the idea is that, you will go essentially for any customers. And as these customers, you can say based on the longitude and latitude, you can see where is the location of this guy, find it there, and say nearby on that cell around this person. So who are the drivers in that things? So again, so the interesting thing is that, so we consider the whole like plane like this. We will divide it into 4. And then, as I mentioned, we are doing it. But the interesting thing is that we are not doing it for all these 4 positions. We will do it only if the density of the number of people here is too many. So then we are essentially, so in some sense, we will focus more on some of these quadrants if there are more demands, if the ratio of the demands, the number of essentially people that we have it is more than some certain threshold, then you will divide it. So in some sense, this is a very good way that you will consider the whole city essentially as this kind of quad trees. And then you know that this is actually, you can change this quad tree, I don't know, probably every night or something, probably will not change it, because those people who are dense, those areas which are dense, you will subdivide it quite a bit. And yes, dynamically, you may also add some areas there, but generally this data structure does not change that much, or you don't need to do it, update it a lot. And the good thing is that, I mean, you can read more about the quad tree structures. I mean, here, this is the whole idea, that we don't want to use slides, everything, such that you can listen when you are driving or anything. So I just want to give somehow the idea that is, when you have this quad tree, it's a very good data structures, especially for this kind of spatial data structures, that you will go there and then you will divide, in some sense, for different areas with different density. You have a different scale, that how much you want to go deeper. And in some sense, you can think about that each of these cells, of each cell is the part that is somehow leaf of this tree, that you don't divide it. That can be handled by essentially a different microservice in some sense, or different databases. You can think about even as a sharding in some sense as well. But the good thing is that when you have such a data structure, you can easily actually find who is near you and who is near to these customers, and then report it and say, for example, this can be the case that among the drivers which are in the cell of the customers, and this is, again, interestingly, the idea is that in these cells, actually, there are, like, in some sense, all of these cells are uniform in terms of the number of people are there. Otherwise, you don't divide a cell more than it is needed. So then, based on that, like you see, just the system can report the 10, for example, drivers who have good recommendations as well, because that's also another thing that comes there. Like, based on the history, you know that these are the good drivers, and based on that, now this is the matching part starts. That now, based on these 10 guys and other customers that are there here, which ones are the ones that you want to send it to send this customer versus the other customers. And so that's actually a nice data structure. I mean, at the same time, you can think about that these drivers also, I think that's the other constraint that we mentioned, that these drivers, they have like, in 3 seconds, we should know that. You can have another things in the memory. You can think like something, some hash table in some sense. It can be like in Redis or other forms, essentially, in the memory, that each of these drivers, at any time, they should just mention their position. And these positions should be updated in this quad trees that I have mentioned. So the interesting thing is that also these are operations that you can do it quite nicely in quad trees, that it might be the case that one driver goes from one cell to another cell. That you should also update it very fast, because now this, essentially, it would be from this server, it goes to another, from this server that is handling it, possibly go to another server that is handling it. So this is like a nice data structures that, again, this is I mean, we will talk probably more about this type of Kubernetes and other microservices and others, but this is an interesting view, I think, that is, that I think it was very lightening, like it was very nice to me that I got this view that sometimes actually these databases that you are designing, you need to combine them with some of the data structures, because this quad tree is a very well-known data structure, but it can be actually combined with some of the databases and makes very nice and efficient systems, such that you can actually handle this number of, I don't know, 1 million writes per day or something like this. But yeah, so these are some, just give some ideas about it, this kind of quad trees, how you can combine it essentially with some databases. You can read more about them on the web. And if you have a request, if you have an app or some service that you'd like to know more about it, we will be happy actually to talk more about this stuff with you as well. But yeah, so this is a nice view. Nishan, do you want to add anything else?
Yeah, no, I think there's some open source projects now that kind of talk about, like H3, for example, I think is built on top of quad trees. A lot of how the search engines are designed, relies quite a bit on this geospatial design. Like, I know one major transformation was kind of using hexagons as representations
Exactly. That's actually a very nice one. Yeah, this is like the one that I heard actually quite a bit. Even at Uber, I heard about the hexagons actually versus. So we are, in some sense, we have a square here. Now, what about hexagons? Yeah, go ahead.
Right. And yeah, essentially like a very interesting property of hexagons is like hexagons are approximating circles. And so you just need kind of this radii to, it makes your algorithm a lot more efficient. So again, if you're interested, we could definitely go into a lot of detail into this stuff. But for now, maybe we should just kind of suffice to say that there are very interesting properties in terms of these data structures and algorithms that we can leverage to build these systems more efficiently.
Yes. Yeah, great. So I think, so it was just some kind of introduction about the complexity of this system, especially those that they have the delivery issues there. And delivery just means transportation, means that we have essentially this data on the map, and how can we handle them? And we talk about some of them. There are some, as Anisha mentioned, there are several of like open source projects that you can find there. Of course, I mean, some of them, it might be quite a match, but probably lots of them are not quite a match. You need to change it. You need to somehow understand the things behind them generally to get a good implementation out of them. Or you need some people who knows about that. We'll be happy if there is such a thing. We can help you on those type of things. And I think this one, somehow we can conclude today's, it is almost like 1 hour, a bit more than 1 hour. And I think we can try to finish this session. I think we covered this thing. Nishan, do you want to say just a summary of the whole things and then?
Yeah, so essentially, we kind of dove into the, I think, fundamental nature of marketplaces, how having multiple sides to a marketplace it requires you to think of many more aspects of the marketplace itself. We kind of talked about what does robustness look like in the face of network effects. We talked about what kinds of incentive structures might help make your marketplace more reliable. We talked about kind of downside impacts of various design mechanisms. We talked about COVID and kind of challenges that that would bring about in terms of, or kind of the things that are really exposed in terms of how these marketplaces that seemingly function without hiccups can have a lot of kind of impact when one part of the marketplace or the chain is disrupted. And then we kind of dove into some of the algorithms and kind of technology fundamentals that enable the high performance that is required in today's marketplaces.
Great. Yeah. So I think we discussed, quite a bit actually in this 1 hour to give some ideas about these things. By the way, also I wanted to add that all of this, in addition of this, as I mentioned, we are live and we are global. I will always say that. Also, if you are just want to, some places that you just want to listen, all of this series actually potentials of e-commerce and other videos that we are making, these are all available through Castbox, and or can be actually, like, if you can go Apple Podcast or Google Podcast, or actually would be also soon will be available at Amazon Podcast as well. So you can just search and you can find them and you can just listen to them. And that's the whole idea, that here sometimes this is some limitations, but maybe some actually features of our things that we cannot go. We don't have slides. We need to talk, but that's it. Somehow the feature that you can listen essentially without really, distracting your watching capability.
The discussion meant to provoke thought and kind of casually listen to. Right?
Exactly.
So trade-offs in terms of not going deep into certain technical aspects by allowing, like, kind of enabling this kind of casual listening from our
viewers. And for me, actually, it works great when I drive long time, because I don't want to change it. I want to listen something, and maybe not the radio is doing the same thing, that the type of thing that I like it. So I would like actually to have this one. But anyhow, these are all available through this podcast as well. You can search and you will find us, and you can just listen to us. So thanks for joining. The people who are in the live and the people who are joining later, watching us anytime later. And we'll be happy to help if you have some problems related to this kind of essentially e-commerce type of things. And great. If there is nothing else, we can finish today. And then we talk in the future ones about, some of the system design and other aspects of things, and hopefully we have some guests as well. Great.
Yeah, thank you, everybody. Have a wonderful rest of the day.
Yeah, thanks everyone, and bye for now.